let's talk about separable differential equations. So to start, let's write out our first example. So for problem 1, we'll have dy dx equals 5x, or actually we'll do 4x times y. So if we want to find what's called the general solution to this differential equation, the first thing we have to do is to separate our variables. And so what that means is we have to separate our y differentials and our x differentials, which we've been circled in green. And we have to get those with their respective variables, which are on the opposite side of the equation here. So we have to match up the dx with our x's and the dy with our y variable. And they both have to be on opposite sides of the equation. So how will we go about doing that here? What we have to do, if I undo these here, we can get the x's on the right side by multiplying by dx on both sides. And we can get all of the y's, the dy and the y, on the left side by dividing by y. If we go about that, we'll be left with dy over y equals 4x dx. Now we can see that we've successfully separated the variables. We have the y terms on this side and the x terms on that side. So now we can go about finding the general solution to this equation. And when we talk about finding the general solution, that pretty much means finding an equation with y in terms of the x variables. So that means we have to get rid of these dy's and the dx's. And we do that by just integrating both sides. And so dy over y is equivalent to 1 over y times dy. And the integral of 1 over y is just ln, the natural log of y. And then if we integrate the right side, we can take out the 4, it's a constant. The integral of x is just x squared over 2. So we can write this integral as 4x squared over 2. And we'll also add our plus c onto the side with the x, but only with the x. We don't put that on the y side of the equation. Now we have to get y out of this natural log. In order to do that, we'll just take e to the both sides, and then we'll write the rest of this up in the upper right corner. This e will get rid of our natural log, and then we'll just have y, which is what we're looking for on the left side of our equation. And that will equal e, if we simplify this 4 over 2, we'll get e to the 2x squared plus c. Now, this is an acceptable solution to this problem. However, another way that we could write it is as y equals c e to the 2x squared. And that will be our final answer for this problem. And the reason we can write that in this way is because think about taking e to the c power. If you take e to the c power, e is just a constant, c is just a constant, so you're just having a constant. And so we can technically just take c and do e to the 2x squared, because this expression up here, that expression is essentially equal to, if I make a little room on the bottom, that expression is essentially equal to e to the 2x squared times e to the c. And so this can just be equal to c, and then that gives us the answer above. All right, moving on to the next problem, we'll have dy over dx is equal to cosine of x over y. So here, we once again have to separate variables, and in order to do that, it's pretty simple. All we have to do is just multiply both sides by dx and multiply both sides by y. So we're going to move dx to the right and y to the left. And that's going to leave us with y dy equals cosine of x dx. And as you can see, we've separated variables now. We have y's on the left and x's on the right. So now this is the step we can integrate at. Integral of y is just y squared over 2. And the integral of cosine x is just sine x. And we have to add the plus c on the side with the x's. So now we have to isolate just y. So we'll start by multiplying both sides by 2. And that's going to leave us with y squared equals 2 sine x plus c. Don't put a 2 in front of the c, because the c can absorb that 2 and just becomes another constant. So there's no need to put that 2 in front of the c. Just put it in front of the variable where we have our x. Now, if we make some room up above, we can see that we have to get rid of the squared on the y. And so we'll just take the square root of both sides. And then we have, as our final answer, y equals the square root of 2 sine x plus c, and leave that c under the square root. And just one more thing, make sure you add your plus or minus in front of the square root to express all possible answers for this solution to the differential equation. And that's your final answer. Okay, for our third example, let's again start with dy dx, and now we're going to have it equal x y squared plus y squared. So for this example, the Renschriftungen is that now there's a plus sign here. So instead of that big multiplication mess that we had before, now we're just adding two separate terms. So we have to think about how to deal with that. Let's start by just rewriting our dy dx here. And in order to simplify this right side, the clue here is that there's two y squared terms. There's one here, there's one there. And when you see that, you have to think, oh, let's factor them out. And so if we factor out a y squared, that leaves us with x plus 1, something that will be much more workable for us to solve this equation, because now we have two distinct terms that are multiplied together that we can manipulate in order to separate variables. So in order to do that, what we can do is just divide by y squared. That'll put the y terms on the left, and we can multiply dx, and that'll come to the right. So doing that, that'll leave us with dy over y squared equals the quantity x plus 1 times dx. And there you go, we've separated variables. So at first this kind of looked a little bit scary because we didn't have everything multiplied together. But as you can see, it's simplified quite nicely into two integrals that are very easy to solve. So now we can integrate both sides. And I'll clear out some space up here. Okay. The integral of 1 over y squared is just negative 1 over y. And then the integral of x plus 1 is equal to x squared over 2 plus x. And don't forget that plus c. Almost forgot the plus c. Okay, so now let's just clear this out. Now that we have this, we have to think about what we can do with our y on the left side. And first, what I'd like to do is just get rid of that negative sign. And we can do that by moving it over to the left. And so if we distribute that negative on the right side, I may have said the left side there. I meant the right side. We're going to move this negative over here to the right. It'll be negative x squared over 2. So just flip the sign of all this stuff, except the c. Leave the c positive because it's just an arbitrary constant. Minus x squared over 2, minus x, and then plus c. And actually, there's a mistake here. This should be 1 over y. And so now we can't leave this as 1 over y. It needs to be y. So what we're going to do is we're going to take the inverse, or the reciprocal, of both sides. And so taking the reciprocal, we can just write that as all of this to the power of the negative 1. That'll be equal to y equals, let's put this negative on the top now. So we'll take that negative back out of this expression, and we'll do negative 1 over x squared over 2 plus x plus c. And that's the final answer for this. You have to make sure you put all of these quantities on the bottom. And of course, you could mess with this fraction and find another way to write this, but this is simplified enough. It's the correct answer. And again, this negative sign here, I just redistributed that out and I put it on the top just to make it look a little nicer with the positives on the bottom. And that's our final answer for this third problem. Okay, so let's conquer our final problem here. Here it is, dy dx is equal to y squared over x squared plus 1. So for this one, what we can do is just multiply both sides by dx, and then we can, actually, I'm going to go about this in a slightly different way. I'm going to start by I'm going to make it easier for you to see what to do here. So we're going to multiply both sides by x squared plus 1, and then I'll leave us like this. And now you may be a little confused because we have the x's with the y's, and if we multiply dx to the right side, we'll have y squared dx. And that's kind of confusing because these are opposite variables, so we're not really separating the variables here, we're just mixing them up. And so this is wrong. We don't want to do this, but I'm just rewriting it in this form so that you can have a kind of a clearer way to see how to separate these. At least in my view, it's clearer to see how to separate these in this way compared to in the original form. So let's rewrite it like this, which is perfectly equivalent to the first form. Okay, so now if you want to put the x's over here, just divide by x squared plus 1. And if we want to put the y's onto the left side, we can divide by y squared. So we'll just do that, and we'll have dy over y squared equals dx over x squared plus 1. And now our variables are separated, and this looks good. So now we can continue this by just integrating on both sides. And we have a couple integrals here, pretty simple ones, but I'll just erase what's up here. I don't want to jam things in on the side here, make it all messy. Okay, so again, we have the integral of 1 over y squared, a pretty common integral, which is equal to negative 1 over y. And that's going to equal the integral of 1 over x squared plus 1. So think about what that's equal to. We know that that integral is equal to arctangent of x, the inverse tangent. So we can just say arctan of x, and then again, add your plus c. So now, just erasing that bottom. So to wrap up here, what we can do is, once again, we can put this negative onto the right, leaving us with 1 over y is equal to negative arctan of x plus c. And then we can just take the reciprocal, leaving us with y equals 1 over arctan of x plus c. And we can just slap that negative sign on top, or you can leave it on the bottom, whichever you prefer. And that will be our final answer and our final general solution for this differential equation. And that's it for the video. Thanks so much for watching.